Hello, everyone. I'm uh, I'm Henri Tremblay, fellow Java champion, and today you're there to listen to K. Horseman, which is one of my I probably told you that before, but one of my personal heroes because he wrote Core Java, the first book I ever read, and with the book with which I learned Java in '98. I think it was Core Java 1.0. So still the best
All
book
right.
to learn Java
Yeah.
ever.
Thank you very much for the kind words. So I've just finished the 13th edition of Core Java. It's at the printers right now, covering Java 21. So that's franchise is still going strong, although maybe not quite as strong as it was at the time because not everyone reads books anymore. But if you do, you should check it out. So today I wanted to talk about pattern matching and the switch statement. And let me just give you a bit of a background. So when pattern matching first was invented, um, I mean, it was of course copied from many other languages. It's a super useful feature and everything, but it uses a bit of an odd choice of syntax. And at first, I was quite unhappy about that, and I had presentations at several conferences about how horrible the syntax was. And eventually, I realized I should just cut that out instead, saying, how can you effectively learn this? And so that's what this is about. So I will go through some of the stranger features, and I think they will really illuminate what makes these things tick. But as you'll see, when I get into the weeds, the syntax is confusing. And the more you learn, the more confusing it is until I hopefully will reveal some clarifying principles. So it would be a really good idea if you actually went and opened a browser window with the slides. You'll see the URL here on the first slide, and it should also be in the chat just ready to click on. Because later there'll be a couple of polls that hopefully, if my primitive polling technology works, will show me what everyone is thinking about some of these things. And that's right on the HTML slide. So these slides are not in PDF. It's 2024. They are in HTML, that technology that makes the World Wide Web tick. When you get there and you want to navigate through them, you just hit the space bar and it moves on to the next slide. So let me start out with just a bit of a refresher about the switch statement. Here you see the switch statement as it was explained in Kernighan and Ritchie's C book. I just copied the very same example. And if you think about it, the switch statement is really weird. I mean, it's different from if else and all of that. The syntax is completely chaotic. And there's a reason for that. The switch statement was intended to allow the compiler to produce code for a jump table. So in this case here, where C was a character, it could at the time have had a total of 128 values. So they simply made a table with 128 slots and put in jump addresses for this code or the next code or the next code. And that's how it was implemented. You could not code that in C yourself. The switch was there to make the compiler generate the jump table. And so in this case here, the constant rate is sparse enough that we can have a straight jump table, simply index into the table, find the address, jump there, and keep on running. And that's, of course, where the break was necessary, because you jumped here, and at some point you had to get the break out so that you wouldn't fall into the next case. Also, you might say, well, what if these are not just characters, but actual integers? Then you can still have a jump table, and you use binary search to, you have to have pairs of the value and the address to jump to, and then you use binary search to find it. This is a win if you have enough cases. So I'm told by Remy Forax that if you have at least 10 cases, he benchmarked it, then it's a definite win. So if you're ever in a situation in your life where you wanted to program a jump table for more efficient dispatch, and you have at least 10 cases where it really is more efficient, go and reach out for a switch. When I look at the code that I have written over the last 40 years, I can tell you that to me, this situation happened exactly 0 times. And so I always have used if else if. But some people like to use switch because they feel it's optically nicer. It shows that you have a finite number of choices. Other people stay away from switch because of the nasty break. Either way, that's how it was for a long time. So what about that nasty break? Peter van der Linden, in a classic a book, wrote that he had analyzed with his own bare hands the Sun C compiler. This was 30 some years ago. And he found that it had a total of 244 switch statements, an average of 7 cases, which probably means that none of them actually benefited from using a switch. And only 3% had fall through. So fall through is wrong in 97% of the cases, which is kind of an unhappy thing. So in Java, Java 1 then took the switch statement with fall through exactly like it was in C, with selector types that were small numbers. Why did it do that? Because Java 1 made, I think, a very smart decision that they didn't want to retrain programmers. They wanted to simply say, if you know C or C++, we got you covered. We take every single statement exactly the same way. We're not trying to improve on anything at all. Except, of course, they couldn't help themselves. And they had one change in the control flow statements of C and C++. They invented the labeled break, another feature that is probably a little unfortunate, but I can talk about that on another day. Java 5 gave us more selector types, which is pretty reasonable, right? You want to switch on enumerations and, well, on the wrapper types, because that's when autoboxing was invented. Java 7 gave us this selector type of string. Now you might say, how can you efficiently make a jump table on strings? Well, you can make it pretty efficiently if you hash the string and make a jump table where you then look whether you actually got the right string or not. Java 12 to 14 introduced 4 kinds of switch in preparation for pattern matching. And we'll go through that in the next slide. And then Java 17 to 21 later on with pattern matching, type patterns, record patterns, and various refinements that we'll see in great detail. Java 21 gave us unnamed patterns and variables as a preview feature that will, I think, Java 22 or 23 become a full-featured feature. And Java 23 we have as a preview primitive types and patterns, instance of and switch, and I'll give you the details about that because probably very few of you have seen that. And there's more to come. There'll be some kind of a deconstruction feature where you can make switches that are like record patterns, and I'll point that out when we get into the record patterns. And maybe there'll be a nicer syntax to deconstruct arrays or lists or tuples or maps. And at that point, one would have parity with the pattern matching that you'd have in a language like Scala or Kotlin today. So let's talk about these 4 kinds of switch. So there's the classic switch that's been ever since Java 1.0. It's a statement, and each of the cases falls through to the next case unless you have a break. Then there is, as of Java 14, this contemporary switch, which is really much nicer. It's an expression. So if you look at the thing here, it has a value that I can assign to a variable. In each of the branches here, there is a separate value. And it reads super nicely, right? We have a number here, the DOW for day of week. And if it's one of these cases here, then we get one of these values. It has no fall through, so you don't have to worry about, that you somehow get from Monday to Tuesday, which was weird in the first place. So this is a perfectly nice thing. Expression is nice, no fall through is nice. Then of 2 more forms that no one ever asked for were also provided. There is a statement switch with no fall through, which I guess is nicer than a statement switch with fall through. And then there is an expression switch with fall through that I hope no one ever uses. Why did they give us a nice switch, an old-fashioned switch, and 2 more switches that no one asked for? Well, maybe someone asked for them. And so I'm quoting here from the chat. It said, by teasing the desired benefits, expressionness, we want that, better control flow, meaning no fall through, saner scoping, I'll talk about scoping later, into orthogonal features, switch expressions and switch statements could have more in common. The greater divergence between switch expressions and switch statements, the more complex the language is to learn, and the more sharp edges there are for developers to cut themselves on. It is my hope that by the time that we reach the end of this presentation, that you completely disagree with this statement. So as it turns out, that the kind of modern switch that we want, this one, and its pattern matching features, are actually quite far away from the classic switch, and it is genuinely confusing to have them use the same syntax. So let's talk about how that syntax works. So to indicate fall through, the cases end in a colon. Here they don't, so this can't be a fall through. No fall through has the arrow thing that looks vaguely like the arrow in the lambda expressions. When you have fall through, the colon can be followed by statements, as always. And if you have an arrow, then you can't have statements. You can have either an expression, like you see here, this is an expression, or you could have a block if you need to cram more things in there, or you can actually have a throw in case you want to throw an exception. Those are the three things that can follow an arrow. Now, when you have a switch here, how do you know whether it's a statement switch or an expression switch? You can't just tell by looking at the switch. You have to see how the switch is used. It depends on its position. The switch here is in expression position because it's being assigned to a variable. Therefore, it's an expression switch. If there was no string weekday here, then it would be a statement switch. That's how it works. If it's an expression switch, and only if it's an expression switch, then it has a value. The value is obtained either by the thing after the arrow, or if you have a block, then inside the block there can be a yield, and the yield yields the value. Now you can have that in both a without fall through or with a with fall through, and we may see an example or two in just a minute. So that's the landscape of switch as it was there in Java 14. And remember, this was all there for our good, namely to make it easier for us to learn this. To test that, let's have a little survey here. So it would be really helpful if for this survey you actually went to the slides, and you should be seeing these buttons. And maybe if the technology works, you could vote for them. So I'll just randomly vote for one of them and see if this works. And then after you vote, you will see how everyone else voted, so that you're not influenced by that. And so I should hopefully at some point see some of these votes trundling in. But in the meantime, let me just talk about some of the choices and see if, so the question here is, when we look at these various case clauses, how many of these can be valid in a switch statement? And so some of these, I think pretty clearly can't be valid, or maybe not. Maybe they're all valid. So here we are returning a value. Maybe that's a little dubious, because can you actually return a value in a switch statement? The value would be useless. It would be ignored. Is that an error? Is that a warning? Then here, we're also returning a value, right? So that should be exactly the same as the first one. Here we're yielding a value again with a yield statement. Can that be true? Now here we are having a break. What could possibly be wrong with the break? Surely you can have a break. Well, the thing that I'm wondering about is that it's without fall through, right? The arrow says there's no fall through. Can you have a break in a no fall through switch? Now over here we have something where we don't return anything. We're just printing something out. And we only do that half the time. Well, that should be kind of legal because it's a statement. If this was a switch expression, this should surely be illegal, but in a statement. And here we're throwing an exception. Is that legal? So it's all a little confusing. I've now confused everyone so that I've gotten very few takers on the poll. So let me start talking about the solutions here. So the first one here turns out is illegal because the compiler will say, hey, you can't just return a value in a switch statement. That value is not used. It's a statement, not an expression. So this one is wrong. This one here, the compiler on the other hand says it's fine. Why does it say it's fine? Because it does not know what to uppercase actually does. Maybe to uppercase would have a side effect, so it does not give an error. The third one is clearly wrong because the yield, A, is invalid in a switch statement. The yield can only happen in a switch expression. And also, a yield is a statement, and everything that follows this little arrow has to be either an expression or a block or a throw statement, and there are no braces. This one here is completely correct because there are braces, and break is a valid statement, so you can actually break out of, even if you have no fall through, it just breaks out of the switch statement. This one here is invalid for the very simple reason. Yeah.
I'll have a question from by myself, actually. Don't I need a semicolon after the break?
Oh, yes, you do need a semicolon. So, so if you are, yes, if you saw that, then you should count that as an error. Yes, you absolutely need a semicolon.
Okay. Phew.
Yes. Remind me afterwards to fix the slide. There's always something. I thought I copied and pasted this exactly from my code. All right. So, so this one here is illegal because there are no braces around it, and you cannot have, after an arrow, you cannot have a statement, except a throw statement is fine. So this one is okay. So if you said this one was correct, this one here is debatable, maybe it was correct, and this one, if you said either 2 or 3, then pat yourself on the back. And we can see here a bunch of people did that, but also a bunch of people were confused. This has been, in fact, many people were confused. Many more people were confused than got the right answer. And this has generally been my experience with this kind of thing. So these 4 cases of switch are not actually really illuminating. And for all practical purposes, I think what you should do is you should forget the toxic old switch and only use it when you always used it, which probably was very rarely, if ever, and really focus on the new form of switch. And the new form of switch, use the arrows and and use it as an expression, and then it's not too surprising. But if you actually need to navigate this landscape of these 4 possibilities, it's a little tricky. All right, moving on to patterns. So there are a couple of kinds of patterns right now. There's a type pattern where you can say case integer I. That means the selector, you check whether it's an integer. And if it is an integer, then it's bound to the variable I. You can have record patterns where you can say, is the selector. The selector, by the way, is the thing that's inside the switch parentheses. Is the selector a match of a record? And here I picked one of the 2 records that exists in Java 21 called Unix Domain Principal. And when you match it, you can say, is it a Unix Domain Principal? And if it is, then this record happens to have 2 components of type user principal and group principal. Then the variable user is bound to the first component, and the variable group is bound to the second component. You can use var instead of the type here if you feel that it's easy enough for the code readers to understand. So those are the 2 important new patterns, the type patterns and the record patterns. You can use unnamed variables in case you don't want to bind these things. You can't just say case integer. You have to say case integer something. But if you're not really interested in the integer, you can name it as an underscore as of Java 21 as a preview feature, soon to be regular. And also here with the record patterns, you can do the same thing. You can use guards. So you can say case string s, and then you can attach some property and say here, you should only want to match this when the length of the string is greater than 0. You can have a case null and a case null comma default. And that's it. Let me just go back so that you can see it all on the same screen. So this is not super complicated right now. We have 2 kinds of patterns. We have this little nicety with the unnamed variables, not too complex. You have these when guards. Notice also, by the way, that in the when guard, S is now the string. It has been cast to the string, and you can use it in the guard. And finally, you have case null. And it can only appear by itself or with a default. In an earlier version, you could combine it with others, and that was then thrown out in preview because it was confusing, which is a good thing. So not super complex. Unfortunately, the devil is in the details. So like I already said, the thing that's inside this switch, and this braces here, is called the selector. And let's look at what selector types we can have. Now in Java 1.0, we could have int, short, byte, and char. You can't use long and double and those things and float because it was not really amenable to having an efficient jump table. In Java 5, like I said, you have the wrapper types and enum. Java 7 added string. And now in Java 7, you can have any reference type. Oops, that's a typo. Any reference type would do. Not any other primitive types, those will come soon. So as of Java 23, all primitive types will be fair game. And at that point, the selector can be any type at all. Now, before the pattern matching switches came along, there was a simple rule that says if the selector, the thing inside here, has a particular type, and then the case labels, they had to match that. And the technical term was they had to be assignment compatible. So for example, when the selector type is integer, it's okay to have a case 5. You don't have to say like case new integer 5 or something. They are assignment compatible, and this the standard says exactly what that means. So knowing this little tidbit, here I offer you two different statements. No, expression. This is a switch expression, and this is another switch expression. And which of them is legal? And which of them are legal? Yeah, there's a question of, I guess, this assignment compatibility thing. That's all we know about. Because here we have a case 0, we have a case with an enum. So just from your intuition about switches, after all, the reason that we're using the switch for pattern matching, and these are all pattern matching features already, because here, this is no longer, it's an object, right? This has type object. So this is not a switch on an integer, it's a switch on an object. This is not a switch on an enum, it's a switch on an object. So these are the new features. The reason to use switch is to harvest our intuition from the classic switch. And so let's see how well that goes. So I'll see if I get someone else who has the courage to put in a vote. That's too bad, so I'll just vote. And so I'm voting for C, because that's the right answer. And let's see why. So this thing here is not legal because this is not one of the classic types. It's a new type. And in that case, you cannot have any of these cases. So you're not allowed to have a case with a constant if this thing is an object. You're only allowed to have a case with a constant if this thing is one of the classic types, and then it has to match. So it would have to be integer or int or byte or something to match the 0, and it would have to be string to match the empty string here. So it's not valid. So let's now move on to this beauty here. And well, what do we see? It's exactly the same thing, right? We're switching on an object. But here, this case is actually perfectly legal. Why is it legal? Well, let's go through the rules here. So it was a little unfair that I'm not telling you the rules first, but I just wanted to see how easy the intuition here is. So you can't have constant labels when the selector is object. What if you want to do that? Then you have to do the somewhat cumbersome. You have to say case integer I when I equals 0. You can't yet say case int I, although soon you will be able to. And then, of course, there's going to be a question about null. But that's what you can say today if you wanted to have an object selector and you want to catch a 0. And you can't have constants in record patterns either, by the way. You can't say case point of var x comma 0. You'd have to say case point var x var y when y is 0. That's the way it is. Maybe a little sad in Scala and in Kotlin. You can of course do this, and it makes your code a little simpler. Now with enum, the world evolved differently. So when you have x here as an object selector, you can match an enum constant. The rules are just different for enums than for everything else. Note, by the way, here the enum had to be qualified. X is an object, so we don't know the enum of what, and we have to put it in here. If you remember how the classic enum switch worked, there you'd never put in the name of the enum itself because it was inferred from the type of the selector. Now the type of the selector is object or not enum. The inference is no longer possible, so you can do that. And for making the rule simpler, you can now do that in your classic switches too, although you probably won't. Why did they do it like that? So why give the complexity of different rules for these for integers, strings, and enums? Because for enums, it's really kind of useful to do this. So a typical situation is you have a sealed hierarchy. So here I have my classic example for some sealed hierarchy, some JSON primitive that could be a number or a string or a Boolean. Well, a number or a string is a record that wraps the value. And a Boolean, there's only 2 values. So I don't really want to have to use some other record for this. I just want to use an enum. And I have these 2 values, false and true. And then if I want to use this to make a match on this, I have a JSON primitive P. There's 3 possible cases. It could be a number or a string, or it could be a Boolean. And then to match the Boolean, you can actually match it like that. In this case here, I could set case JSON Boolean dot true. And the beauty is that then the compiler would know that the switch is actually exhaustive. But here I've chosen to have a default just to save myself a few letters. So you just have to remember that while enums are perfectly fine for pattern matching, that for general pattern matching, you cannot use constants that are not enums. That's just the way these things have been built. Moving on to the next fun subject, that's null. Of course, there has to be trouble with null. It's Java after all. For historical reasons, there is a discrepancy between 2 kinds of pattern matching. You can do pattern matching both with switch and with instance of. And with instance of, it reads like this. Here we're checking if J is an instance of a JSON number, and we can do the same kind of matching thing that then it pulls out the record component if the match was successful. If the match was not successful, then nothing happens. Then, of course, there's no sense in pulling it out, and this statement would be meaningless. So it's kind of similar to a switch, but you would use it if you just have one case maybe where you feel that the syntax of the switch then is too much. What happens if J is null? Well, null is never a match in instance of. It just quietly matches nothing. Now let's look at the equivalent switch. Here's how you would write this thing as a switch. And you can see that here the switch definitely is shorter and sweeter. So you kind of want to do that. There's only one teensy different, that in this case here, if J is null, nothing evil happens. In this case here, what happens? Well, the same thing that has always happened with a switch when the selector is null. Namely, it throws a null pointer exception. This is how switches have been ever since Java 5, because before Java 5, you could only put those 4 short primitive types as the selector. But as of Java 5, you could have reference types in the selector. And when the selector was null, then the switch throws an NP. Same thing is still true today. Except you can make a switch null friendly if you add a case null. So if there is a case null, the compiler checks whether any of these things has a case null. In that case, it turns it around. The switch is null friendly, no more null pointer assignment, but instead this case is executed. Not really too difficult to understand. And what you should do is just scan every modern switch and see if there's a case null. In that case, you don't have to worry about an exception. So let's put this to it. I mean, how hard can this be, right? No. So here I give you 3 different situations. And so we have a record box that simply has some value inside, some contents inside that it boxes up. We're setting it to null. Does this switch throw a null pointer exception? Here, we are wrapping a null inside the box. Does this switch throw a null pointer exception? And here, let's see what we're doing. We're having a box in a box, but we're already at the outer level. We're putting a null. Does this switch throw a null pointer exception? This switch in particular looks a little tricky because it doesn't even get to this inner level, does it? Right, because the outer level is null. So what do you think? Okay, so let me work through this here. The first one here definitely throws a null pointer exception, right? It's a classic switch. There's no case null, and box is null. So null pointer exception, count 1. The second one here does not throw a null pointer exception because why should it, right? Boxed is a box of null, so this S here is null, and it'll just set unboxed to null. So far we have 1 NP, no NP. The third one here, you would think that if it tries to unpack the inner box, well, how on earth is it going to unpack it, right? It can't. There is a null in here. There is no inner box. I would have to throw a null pointer exception. But as you will see on the next slide, cruelly, it does not. And so the correct answer is B. And so that was not the majority answer. All right, so what goes on in that third case? That's really the question. So there's really no surprise when the record selector itself is null. It's also okay to have a null component, then the null inside just gets unwrapped. But it is not okay when you have this thing here where it tries to go to the inner one and then extract the S when that is null. And it can't, right? Because it wants to compute something like doublebox.contents.contents where this part is already null. So it has to throw an exception or do something. And so it does throw an exception, but it doesn't throw a null pointer exception. Instead, it takes the attitude that, other things could go wrong, because when you call contents, you don't actually call contents, but the contents method, which could have been overridden by someone, which could have thrown any exception. And it just turns all of those exceptions into a match error that wraps the exception that occurs. So in this case, you get a match error and not a null pointer exception. There are people who believe that this was probably a mistake, and it certainly is somewhat confusing. So you just have to realize that anytime that you unwrap something, there's the theoretical possibility of some of these methods that need to be called, these record lookup methods, they could throw an exception, and they always then generate a match error, even if it's just what to us should be a null pointer exception. It doesn't super matter. It's just weird that it is so inconsistent. All right, moving on. Exhaustiveness. So I'm already giving this puzzler kind of away by the title. So we have these 3 switches, and maybe not all of them compile. So let's see. This is a classic switch, right? We're switching on an int. Here we're using the kind of new syntax. This is also an expression switch because it's an expression position. This here is also kind of a classic switch with an int selector. It's a statement. It just sets a variable to something. This one here is also a classic switch. It has an integer, which is still classic, right? It's in Java 5. It does a bunch of stuff. And it helpfully even takes care, the integer could be null, right? So how many of them compile? Kind of looks like, should they all compile? Well, maybe because I did actually say something about exhaustiveness. There is a problem with this one here, right? It can't possibly really compile because what if x was 4 or -1 or any of any other values? Then this thing has to return a value. And it doesn't say anything, so I think this one can't compile. But this one here, it's a statement. This one here is a statement. So I'll just say one of them can't compile. And this time, that was the majority answer. And of course, it's wrong. So let's see why it's wrong. So switch expressions must be exhaustive. Of course, they must be, because you must always match some case. There must always be a value for every possible input. Classic switch statements need not be exhaustive because they never were. If there's no match, just nothing happens. But, and this is what makes the third one false, what's called enhanced switch statements must be exhaustive. What the heck is an enhanced switch statement? It's one that has a pattern case or a case null, or it has a selector type other than a primitive wrapper string enum. And so let's just go back to the previous slide really quickly here. Is this thing here classic or enhanced? Well, the selector is integer, that's classic. All this stuff here is classic, but here, look at this case null. That makes it modern. This little case null makes it a modern thing, and it has to be exhaustive. The compiler will say, hey, you're not making this statement exhaustive. A modern switch statement must be exhaustive. So that's weird. And there's a simple remedy, and that is that you add a default clause to it with a break or do nothing action, depending on whether you have colons or arrows. So that's really kind of weird. And it's just something to remember that nowadays, if you only use switch expressions, no big deal. Of course, you're going to write them exhaustive. But if you want to use the modern kind of switch statement, because you just happen to have a switch statement and you say modern is better, then you just need to remember they too nowadays need to be exhaustive. That's not bad. It's just something to remember. Exhaustiveness checking is a little bit, well, it's not quite as good as one would like it to be, because of course, when you have guards, then the compiler is not a mathematician. It cannot see that, for example, in this case here, that every integer has to be positive, negative, or 0. So when you have these when clauses, they're not used for exhaustiveness checking. And you still need to put in a default, even though it would never happen. Or you can just replace the last thing with the default. That's something to be keeping in mind. The exhaustiveness checking is nice, but because of the guards, it cannot possibly be perfect. Yeah, so just put in some default case. Also, case null is not used for exhaustiveness checking. Notice this particular example here. I mean, even if we fix it with a default, whether we put in a case null or not has nothing to do with exhaustiveness. It simply changes the nature of the switch from null hostile to null friendly. Yeah, so that's what I just said. All right, here we have another thing. I'm just going to tell you the phrase, and we'll see if it's clear from that. So there's something going on with the dominance checking. So we have two switch expressions here. And so my question is, Which of these compile? Neither, only one, only two, or both. Let's see, why might the first one not compile? I'll just say think dominance and leave it at that. And here, well, same thing, right? Dominance, right? This one here, doesn't it dominate? So I'll let you ponder that for a minute. Oh, wow. That's always good when you get all four possible answers. So I'm going to say that this one here can't compile. And just to be difficult, I'm going to say this one can compile. So that would be this one here. And that was, in fact, the majority answer. Not quite, but it was the most frequent answer. And it's also the correct answer. So what's the deal with dominance? So these pattern switches are different from the classic switches in that they're processed top to bottom. If you recall, the classic switches had one mission in life to be implemented as jump tables. There's no top to bottom. One jumps right to the correct case and then marches on from there. It's completely different from patterns. Why are they then using the same syntax? That's a good question to ponder. And so if there is a case that can never apply because you can't get to it, that's a compile time error. So in this case here, if we have case number n, it dominates case integer I because an integer is a subtype of number. It also dominates the same thing with a when clause. And similarly, if you have a record pattern like this here, and remember this box was a generic type, then it dominates case block string B because this var could have been any type, and this string here is string. So the type system will be put to good effect here to warn you of things that could never possibly match. It's a compile time error. Unfortunately, because of we can't evaluate when is that a case where the when doesn't dominate, except if the compiler happens to know that the clause is a compile time constant. So you can say when true or when boolean.true, and there might be some reason why you might want to do that. Just sometimes people say if true or some such thing, and it's the same logic applies. Now default must naturally come after any patterns because surely default dominates. It also needs to come after or with case null, even though it doesn't cover it. Remember, default has nothing to do with null unless they're combined in a case default comma null. But for historical reasons, default can come before constant cases. So look at this and weep. This is a classic switch. We're having an integer selector. So this thing, except here for this when thing here, which kind of makes it modern, but here the default comes before case 0 because that was always legal in the past, and they did not want to make a different rule now for more modern switches. So for some switches, once you put in a modern feature, they become relentlessly modern and classic rules don't hold. But for other rules, like here with the default that it's okay to put it before a constant case, those have not changed. And you just kind of have to know, or just don't do something silly. Of course, you would never really do this. And so it's maybe not a mistake that really is going to bother you much in practice, except, of course, in these puzzlers. All right. So, yeah. So, yeah, don't do that. And so, just as a take-home assignment, can you ever have a situation where an integer case 404, can be dominated? I mean, it can't be dominated by default, we've just seen. So just for you to ponder whether there's ever such a situation. Send me an email if you figure it out. All right, second to last puzzler, scopes. This one here is probably the weirdest of the ones. So I actually had to look this up and compile this. I had no idea when I first cooked this up what the answer would be. So let's look at what we have here. Here we have a classic switch on an integer selector. We have two cases, and for whatever reason, we now declare a variable here. It's a statement, why not? We are concatenating that variable with this string r here, and we're breaking. So that was the first case. In the second case, that's the default case, we are putting, okay, how's this going to work? Is the scope of this v here, is this thing still in scope, or am I missing a declaration here? So that's something to think about. That's here the sticky widget. Moving on to the second one. This is a modern switch. We are matching three different cases, whether it's a number or a string or a Boolean. In this case here, we are defining a new variable v. Here we're defining another variable v. Can you give it the same name? Here I have a third variable v. And so here it looks like the scope kind of dribbles into the other cases. Here it kind of looks like they are disjoint, but can both be true? So it seems like only one or only two should compile, right? Or maybe neither. Maybe I made another mistake that I didn't see. So I've gotten one answer here so far. No. Right now I've gotten a few more answers, and they're all different. So everyone has a different opinion on this. I am going to say that they both compile because no one gave that answer. Oh, now three people have given that answer. All right, let's have a look at this. So variables inside a switch. There's three different ways you can get a variable inside a switch. The first one, completely harmless, inside a block. And then it goes to the end of the block. You can have it in a pattern. And then the third thing is you can actually put it inside a statement, and there has to be following a colon, right? Otherwise, it would have to be in a block, which we already covered. So, and the question is, what are the scopes? The block scope is unsurprising. This is the scope. Nothing wrong with that. The pattern scope does, fortunately, the nice thing. It ends with this case, even if you have fall through. So remember, there are fall through switches with pattern matching, but no matter what, it's kind of sane. It ends at the end of the case. This third scope here is really weird. This existed since Java 1.0, and in fact, it existed in C. You can declare a variable anywhere inside the switch, and its scope is from the point of declaration until the end of the switch. It's not super useful because if you jumped into here, then of course it's not been assigned to anything, and so you actually still have to assign it to something. Otherwise, you would get a definite assignment error. In C, that didn't matter, right? So what if you had unassigned variables? But in Java, it does get tracked. So in Java, this feature is completely useless. I'm sure I've never seen this in the wild, but there it still is. And so that's the problem with using the classic switch. The classic switch has so much historical baggage that one now still has to kind of integrate into the modern features, that it is a bit troublesome. All right, last thing, and then we'll have a few more minutes for Q&A if there are any. This is a look into the future, primitive type patterns. So I first tell you what the rules are going to be. So soon you will be able to do what you've, I'm sure, always wanted to do. You can use the selector types float, double, long, and Boolean, and the wrappers, and constant cases with those types, because that actually will make the feature a little bit more regular. There's no arbitrary restriction on the selector types. You can also use instance of with primitive types. So if you say if x instance of int n, then it's going to check whether x is an int. And if so, then it's going to make n that integer. So x could be a long, for example. So if x was this long here, then this test would fail at runtime. It would throw, I think, a match error. And no, it wouldn't throw any error. It would just fail. It would just skip this. It's an instance of, doesn't throw any exception. So it would just not do anything. And whatever you put after the if doesn't happen. And you can also do that in type patterns. So in a switch, you can say case float f. And so this would test whether f was a float. And here we test whether it was a positive float. You can do it in record patterns. Remember these generic things where JSON number could have like a long value inside here, or no, double. It was a double. And here we test whether that double was actually an integer. Here, this thing had an object value, and we're testing, was it an integer, meaning a wrapper integer because it was an object, and also was it not null. So I read through the JEP, and I said, this looks like a lot more complexity. So here I have an integer here, and now I can check at runtime, is it a short, is it a float, is it a double, is it a number, and which of these pass? So without the benefit of reading through the JEP, or maybe you can read through it very quickly, what do you think? How many of these here return true? The short one seems like it doesn't, right? I mean, that's what this feature is surely designed to do. This thing is not a short, and it can easily tell. What about a float? What does it mean to be float? I mean, I can right now in JShell, I can assign it to a float, right? And I'll just cast it as a float, and I'll get something. I might not get all the digits. As a double, well, surely I can make this into a double, right? As a number, I don't know. I mean, it's not a number because it's not an object, but it could be converted to an integer, which is a number. So I should have had a fifth option that says that I have no idea, because the truth is I don't really know. But if I had to guess what I'm hoping what this feature will do is that I'm pretty sure this must return true because in the past it had returned true. They can't change its behavior. I think this should work. I think this should fail. And I think the float should also fail because if you actually try this out as a float, you lose some digits. So I'll just say, hopefully 2 of these are right. And that's no, it's not the majority answer. I read the JEP. I couldn't figure it out from the JEP. The implementation is not yet available. So there are more puzzlers to come in the future. All right. So enough already. So the idea of using switch and instant of a pattern matching was to leverage existing knowledge. And it does that to a degree, right? We're familiar with the syntax of switch and instance of, so we already have a starting point. The devil is in the detail. Sometimes that existing knowledge does not match the domain of pattern matching. And then you have these little weirdnesses. And where does it happen? Fall through. I can come up with 3 other fall through puzzles, easy. Constant cases are kind of odd. Primitives and wrappers give some complexity, as they always do. Of course, our old friend Null. And then this thing with default that in the past, you could put the default somewhere in the middle, for example. Or the default dominates Null, but it doesn't cover it, those kind of things. So, yeah, we could say this is all terrible, but actually, pattern matching is really nice. And so you don't want to say, I'll just never use it. But how can you safely use it? The first thing is just don't use fall through. Just always use the arrows. Even with switch statements, in 2024, there's very little reason ever to use fall through. And now you can have an easy way to avoid it. Use switch expressions whenever you can. Switch expressions, I think, are sane, are better behaved. And but if you now use switch statements, make the switch statement modern so that you still get the coverage check. And have a case null. A case null is good, unless you really want the thing to throw a null pointer exception. But then to have a heart and say case null arrow throws null pointer exception. That way, it's super clear what you want. So case null is good. Of course, sort your cases so that the specific ones come first and the more general ones later, and then default comes last. And yeah, don't use these switch scope variables. I'm sure you've never done that anyway, so it's not too worried about it. So the sweet spot for pattern matching is the instance of patterns are generally nice. So whenever you're writing instance of today, instance of is surely then followed by a cast, and you should just rewrite it as an instance of pattern, avoiding the cast. You save yourself a bit of ugliness. And so that's kind of a no-brainer. So you can Google your code for instance of, and not Google. You can just grab it for instance of and apply those changes right away. Otherwise, with switch, I don't know if there's a humongous number of situations where you can rewrite your existing code and use pattern matching. Pattern matching really works best when you have a hierarchy that was designed for pattern matching, like that JSON hierarchy that I have right now today. Of course, you're using some existing JSON library that was not designed for pattern matching, so it does not do you a world of good. Although, it's better than nothing. Maybe you could still use a type match instead of having a bunch of instance of checks that you probably have today. But presumably, people will in the future design these hierarchies with pattern matching in mind, and then that'll be much nicer. One day maybe optional will work like that, and you can match on optionals. That will require deconstruction so that you can tell whether an optional is empty or not empty. Optional is not a record; it never will be a record, and so some other feature needs to be provided to tease optionals apart, and that's this deconstruction that's in the work. So there is more to come with pattern matching, but we're kind of getting towards the end. All right, that gets me to the point where I once again want to show the cartoon, which I think now will be clear to everyone. And we'll see if we have a few minutes for questions. Are there any questions?
No, they're awfully quiet.
Okay, so I've stunned them with these mind-numbing details.
Maybe. No, I think you just explained well. And actually learned a lot of things. It was fun, and yeah, some of the edge cases that I was aware of.
Yeah, no, I gave this talk last year at JCrete, and no one wanted to listen to it, and so I only got to give it because there was a blank slot, and I just grabbed it and said I'm going to talk about this, and then a surprising number of people came, and Maurice later said that we laughed, we cried, we asked for more.
He's right, because it's rare that we dig in it that much, and I didn't know, because normally when you do examples, you do the easy things, like the meaningful things, but as soon as it goes crazy, it gets strange.
Yeah. So I think the meta lesson from this is that if you are ever in a situation where you want to build upon something that's familiar, like in an API, or not many of us write our own programming languages, then it's a really good question to ask whether that's going to bite you later.
Yep.
In this case, had they just used match like in Scala, none of these issues with backwards compatibility would have come up.
Yeah, that's true. That's true.
And if you have a new language like Kotlin or Scala, of course you have the luxury of doing that.
Yeah, here it's more complicated.
And yeah, no, there was at the time there were some people who said this should absolutely be done, but most people felt that there was benefit in leveraging the existing syntax.
I followed the discussion on this one, but yes, I now use the arrow all the time, so the new syntax The case null is pretty awesome because it saves the stupid ifs that we were putting on
Yeah,
top.
exactly. And also, once you put in the case null, your switch now becomes a modern switch, and you get the exhaustiveness checking.
Yeah, so magical.
Yeah.
And so
All
the
right.
recommendation, do follow the recommendations. They're actually accurate. And is there any question about looking? I don't think so. Oh, someone does have your Core Java 1.0 book in his library somewhere. I don't have
Okay.
it anymore. I'm sad about
Yeah. Well, I don't either, sadly. I moved so often that at one point it got lost.
that.
So the later ones I have in digital form, but I do not actually. I'm sure it's somewhere in the Internet Archive.
Probably. I looked for the cover at some point for some presentation I was giving, and it's actually hard to find. Um, but thank you very much.
Okay. Well, thanks
It was a pleasure.
for hosting it. So the conference is almost at an end. I hope everyone's enjoyed it. And if anyone needs to get a hold of me, you know how to find me.
Yeah, they seems all really happy. So
Yeah.
thanks a lot.
Okay.